This is a demonstration of how we can convert a decimal number to its octal equivalent for fractional numbers. Okay, so say for example, we have the decimal number, the decimal fraction 0.90625. So that is in decimal notation. By the way, I always put the subscript for the base of the numbers because it would make the numbers be clarified on what base it is. Okay, so we will start with 0.90625. Okay, so for our solution, we are going to divide our solution into 3 columns. The first column is a series of multiplications. The second column will be the the product of our multiplications, and the third column will be the column for all the integral parts of each product. Okay, say the integral part or the whole number part of each product. Okay, so we will start now. So first is we are going to start with the original number, which is 0.09 or 0.90625, and we will, as I've said, we are going to do a series of multiplications for the first column. Now, what will be our multiplier? Okay, our multiplier will come from the base of the numbers system that we are going to convert our decimal number into. Since we are going to convert into octal, and the base of octal is 8, so our multiplier is 8. Okay, so that is how we can get or wait where 8 comes from. Okay, so when we are going to multiply 0.90625 by 8, if you'll use your calculator, you should get 7.25. Okay, that's our second column. If you'd add an equal sign here, that would be fine. But for now, I just omitted it. Okay, so the third column is we are going to get the integral part. The integral part of the product is 7, or the whole number part. So we will take that out here, the 7. So that's it. And as I've said, we are going to do a series of multiplications. Where do we get the next number to be multiplied by 8? We are going to get the fractional part of the first product. That is 0.025. Okay? So that is 0.25. Okay, sorry. So 0.25 times 8, that would be equal to 2. Okay, or in this case, we are going to specify 2.0. Okay, so since we are going to take out the integral part of that is 2. Okay, now we are supposed to get the fractional part and do again a series of multiplications or another multiplication. But since our integral part or fractional part is already a 0, so multiplying 0 to any number is already 0, so we will stop from there. So now from here we can already derive the equivalent octal number of our original decimal number. So but since we are going to converting a fractional number, we read from bottom to top from our third column, from here, that is from top to bottom. Okay, so how do we do that? That is, we can now conclude that 0.90625 in decimal, that is equivalent to point or 0 point. Why do we put as a point or a radix point? Since this one is less than 1, so we have a decimal point, we also put a radix point here. So then that is, next to that, we will copy the first digit from here of the octal equivalent. Then the second is, that is 7. And the second one is 2. So that is our octal equivalent. Okay? So that is how we are going to convert a decimal number to its octal equivalent for fractional numbers. But this is especially for the cases of terminating fractional numbers. We say terminating because at some point you will get to a point where the fractional part is already 0. So it's a terminating fraction.